I'm Anil Kumar sharing with you a test question on application of dot products. This is a communication question on dot products. The question here is, explain if the following statement is true or false. If dot product of vector u and v is equal to dot product of vector u and w, then vectors v and w are equal. That's the statement. Is it true or false? You can pause the video, answer the question, and then look into my suggestions. So let's begin by understanding the two dot products. So we are given dot product of u and v is equal to dot product of u and w. Is it okay? Now what is dot product? It is magnitude of the two vectors, their product, times cos of angle between them. Let's call this angle as alpha, right? For the other two, it is again magnitude of these two vectors, product of that, and cos of angle between them, let's call it some other angle, beta, right? Now solving this equation clearly indicates that magnitude of v times cos of alpha is equals to magnitude of w times cos of beta. Do you see that? So that's what it means. It does not necessarily mean that v is equal to w, right? V can be equal to w only if alpha and beta are same, right? So we say this statement is false. It is true only if the two angles are equal. You understand? So that is how we can actually prove it, right? Now you could also prove it by providing counter examples, right? So you could say, give you counter examples, you can say counter examples to prove. For example, if I take a vector u as, let's say this is 2 and 3, this is vector u dot, for example, vector v could be 0 and 4, for example, right? Now, if I do the dot product for this, what do I get? I get, what we are taking here is, this is vector u for us, and this is vector v for us. Is that okay? So, if I do the dot product, I get 2 times 0, which is 2, 0, and 3 times 4 is 12, right? On the other hand, we want to just make 12 here with a dot product. So I'll write again a vector u, which is same as 2 and 3. And to get the result 12, I could get like 3 times 2 is 6, right? And 2 times 3 is also 6. Do you see? So I could get this also as 12. You get an idea, right? So in this case, what you clearly see is that the vector w and v, they are not same, right? Their dot product is 12. You get an idea, right? So that is kind of very important to understand. Now let me extend this a bit more. So what I'll do here is I'll just consider the vectors in coordinate 1 just for ease, and I'll consider vector u along the x-axis. I mean, it's not these vectors. Let's say vector u is like this. This is my vector u, right? So, and let's say this is my vector v. So we say magnitude v cos alpha, let's say this angle is alpha. So v cos alpha will be this. So this portion is v cos alpha. Do you see that? So that is v cos alpha for u. This is, let me write down this as u, the vector u, okay, and this is vector v. Now, if I want v cos alpha to be equal to w cos beta, I could have another vector whose x component, or we can say projection of that vector on u, is same, right? So that could be a vector like this. Think like this. Okay. Now, if this angle is beta, then let me call this ON. Then ON is also W cos beta. So from this you can see that we could have different vectors resulting into same dot product, right? I hope that helps. You can always share and subscribe my videos and feel free to like them, right? Thank you.